Students, welcome to my YouTube channel Educational Revolution. Today I am going to explain about de Broglie theory. De Broglie theory, it is important topic and frequently asked question for different level like BSc level. Now it is written here in 1924, de Broglie proposed that the electron light behave both as a material particle and as a wave. That is, the electron has dual character. According to de Broglie theory, electrons has dual character, or electrons show two types of properties. One is wave, and another is particle. So it has dual character. Now, using Planck's quantum theory and Einstein mass-energy relationship, de Broglie derived an equation for calculating the wavelength lambda of the wave associated with an electron. Based on Planck's quantum theory and Einstein mass-energy relationship, de Broglie gave an expression to calculate wavelength of electron, which is known as the expression or equation of de Broglie theory. Now the equation, according to Planck's equation, E is equal to mh nu. This is consider the equation first, where nu is frequency and h is Planck constant. By Einstein mass energy relationship, E is equal to mc square, which we consider the equation second. Now comparing the equation first, this equation and this first and second, we get mc square is equal to h nu, because E is same, so we can write here mc square is equal to h nu. So mc square is equal to h nu. We can put the value of nu is equal to c by lambda, since lambda is equal to c by nu is equal to c by lambda. So mc square, now the equation mc square is equal to h c divided by lambda. So c cancel each other, so only one c remains here. So mc is equal to h nu, mc is equal to h divided by lambda. We can separate lambda from here, so lambda is equal to h divided by mc. This is considered the equation third. This is the main equation. Further, lambda is equal to h divided by momentum of electron. M indicate momentum of electron and c indicate p. It is not necessary to write here, but I wrote, so you can neglect this, but you should write this equation 3, where lambda is known as de Broglie wavelength, and this equation is called de Broglie equation. This equation is called de Broglie equation. Now, experimental proof of dual nature of electron, that is electron so two types of properties that I have already said. One is wave, and another is particle. So dual nature, it means dual nature. Now, Davison and German in 1927 experimentally proved de Broglie hypothesis. They succeed in diffracting electrons wave from a nickel crystal. Davison and German, two scientists in 1927, they conducted an experiment to prove de Broglie hypothesis, and finally they succeed in diffracting electrons waves from a nickel crystal. nickel crystal. Later, in 1928, Thomson and Reid extended the research on electron waves. High speed of electrons were diffract by very thin metallic film. They used to method similar to the Debye scatter powder method of X-ray analysis of crystal. What this is trying to say is that this is nickel crystal, thin nickel crystal. When electron passed from here, electrons get collide here and they get scattered and diffract. So, and this can be verified by X-ray analysis, which is similar to Debye scatter powder method. Now the properties of wave matter. Smaller particles to have mass, hence they have the quality of matter. This point highlights the matter. This point highlights the property of matter, because very small particles also have mass, so which we call matter. Second point, if we consider particle as wave particle has similar properties as the wave, example wavelength, amplitude and frequency. So wave, like as wave, smaller particles shows wavelength, amplitude and frequency. So this point highlights the properties of wave. At last, smaller particles like electron, neutron, proton, neutron, when move, their nature becomes same as matter and wave. Electron, proton, neutron shows two type of property, that is matter and wave. So this third point highlights both property, that is wave and matter. So that's all for today. We will meet in next video. Thank you.